Okay, so the area of non-right angle triangles. So the area formula. Let's have a look at a triangle again. Okay? And we're going to label this triangle A, B, and C. So effectively, how you use this triangle, or how you can work out the area of this triangle, is quite simple. We're gonna look at how this is related to, say, when you know a perpendicular distance. So the regular area formula of a triangle, okay, is A is equal to half times the base times the perpendicular height. So the perpendicular height was the important bit. It was the height that made a right angle with the base of the triangle. Now, a lot of the times in non-right angle triangles, you won't actually have a perpendicular distance, or you won't have the means to find one. Okay, so for example, we might have one that looks a bit like this, which is a bit skewed, okay? Where we could work out what a perpendicular height is, it's not always going to be exactly halfway. And if you haven't been given the information, there's no way that you can actually find it, okay? So, to find the area in a triangle that's not right angle, doesn't have a perpendicular base or height, okay? And this can be applied to right angle triangles as well, don't get me wrong there. It's just, this is the way that we find them in this case. So I'm going to use AREA, so area, for the area of this one, because we are going to be using A's in as well, and I'm not referring to this A that's sitting up here. Okay, so not that one. This is referring to the area. So the area is equal to, now let's just write it out, it's going to be a half times. Now we need to pick an angle that we're going to be going from, so I'm going to pick this C here. Now, if we're picking this as our angle, so a known angle in the triangle, then we need the sides either side of that angle. So in this case, this one here and this one here. So it's half times A times B times sine of C. And this is going to give us an area of any non-right angle triangle. Okay, and that's it. Now, the reason why this is directly related to when we have a perpendicular height, well, if I have a perpendicular height, the angle that I know is 90 degrees. Okay, because I'm using the height and the base, which are on either side of the angle, just like over here. So here's my angle here. I'm using this one here and this one here, just like I'm using over this triangle here. What is that equal to? Come on, it's nice and easy. It's only equal to 1. So effectively what happens is this part at the end just becomes 1, and you're left with that. Half times base times the height. So this is needed for basically when we don't have a right angle triangle. Because when it's not a right angle, sine of C is not equal to 1. This is like the missing link to effectively generate an area formula for any type of triangle, no matter what it is. Whereas the regular area formula for a triangle only works on or when you have a height and a base that is perpendicular to each other. Okay, so that's the formula. That's it. Area is equal to half times A times B times sine C. So let's have a look at it being applied in a question. The area sides of a parallelogram are 12 centimeters and 15 centimeters, and the angle between them is 50 degrees. Calculate the area of a parallelogram correct to the nearest square centimeter. Okay, so nice and easy. Let's start by drawing a parallelogram. So you might remember a parallelogram looks something like this. Okay, and what we know about this is that its two adjacent lengths are 15 centimeters and 12 centimeters, and that the angle in between is 50 degrees. So you might be saying, well, how is this related to the triangle formula? We have a triangle formula. Well, what happens if I just do this? If I cut my parallelogram in half, diagonal, what do we end up with? We end up with two triangles. But again, you might say, well, how does that actually help us? We can only find the area of one of those triangles. Well, not necessarily, because using the fact that a parallelogram is a pushed over rectangle in layman's terms means that this angle up here is also 15 centimeters. Sorry, that length is also 15 centimeters. This length is also 12 centimeters, and this angle in here is also 50 degrees. So in fact, we've got two angles or two triangles of the exact same dimensions. Now that we've got this, there are no perpendicular heights in this case, so we're going to have to use our area formula. So the area of the triangle is equal to, so it's a half times 12 times 15 times sine of 50 degrees. Okay, so we put that into a calculator and we get 69 centimeters squared. Okay, because it's area, we've got square units. Now the area of the parallelogram is equal to 2 times the area of the triangle. But the area of the triangle is equal to 69 because there's two of them. So it's 2 times 69 centimeters squared. So the area is equal to, put into a calculator, 138 centimeters squared. Now, you might actually be given, in some situations, what the area of your triangle is. So I'm just going to quickly do this on the side. We're not going to do an example of it because it is just a simple application of algebra. But say here's your triangle and you're told the area is equal to, I don't know, 36 centimeters squared. Okay, and you're asked to find what this angle is here, given that that's 5 and that's 7. Okay, so it's pretty easy. All you do is just substitute your values into your area formula. Okay, half AB sine C. Okay, and then just rearrange it for sine of C. Okay, like it's pretty straightforward. Okay, it's just simple algebra. You guys know how to do that. I don't think I need to go through an example. However, if you would like me to, just let me know and we will do so. Okay, that's it for the area of a triangle, or a non-right angle triangle, I should say. Okay, and we're going to move on to our last video for this little subtopic of the sine and right angle triangle formulas.